All right, everybody, we're going to do a quick little comparison between carburetors and fuel injection. I kind of give you that transition across. So I do have a regular presentation just on carburetors, but I wanted to do a little quick overview of carburation and also fuel injection. So this won't take very long, but we're going to have some fun doing this. So kind of getting started into this, let's go ahead and bring up the PowerPoint first. And here we go. When we talk about carburation, and this is going to be kind of an overview, we'll talk about some of the fuel injection basics too. So we're talking about a comparison between this big boy right up here, the carburetor. This is just one form of carburetor. Please don't think this is the only carburetor out there. There's many, many versions of the carburetor out there, and I'll try to talk a little bit as we go along too. And of course, our fuel injection, this being the direct injection system right down below here. So the idea is to give the perfect fuel mixture, which carburation lacks a big portion of because of the way it's actually put together. And it was very good at its time, but with the change in regulations of fuel emissions and fuel economy, that kind of slowly put the carburetor out. With the technologies growing, getting getting computers on cars, and the advent of fuel injection really brought that up to what we're at right now. So you're going to have fuel injection in pretty much every car unless you have an older car, and there is some advantages to this too. So with carburation, we have some basic things. One, the carburetor is bolted onto the intake manifold. We had very crude intake manifolds too, which was one of the things that kind of gave a carburetor a disadvantage. But later on, we started doing high-rise intake manifolds and stuff like it, which helped, but it still had its downside to it. So the basic, carburetor, there is, a throat, as they call it, up on top. And then we had a venturi affair right here. We'll talk about the importance of that in a little bit. And then the air fuel mixture down here. We had our throttle valve or throttle plate. And then we have a float bowl. Okay, keep that in mind because this is going to be part of what you're going to need to know as we go along. So the basic carburetor system, circuits, we had the float circuit, we had the idle circuit, we had the off idle circuit, some acceleration circuit, which usually was a couple stages to it. And then we had a high speed, full throttle, and our choke circuit. Now, I'm not really, I'll show you a electronic carburetor, but we're not going to get deep into that. I'll do some more videos on that as we go along. So the float circuit, basically what it did was had a storage unit for fuel. Even though we had a storage unit back in the fuel tank, we had to have a storage unit to allow enough fuel so we could actually use the venturis and the fuel, the accelerator pump. All this needed to be in place so we'd be able to mix that fuel at a precise, which that is a discussion that we could have just on how precise the carburetor was. Anyways, so the basic float system, we had what they called a needle and seat. So here's that needle, there's the seat, and that needle and seat are what controlled the fuel coming in. Now, we did have problems with overpressurization in the fuel system. So your fuel pump would maybe make somewhere between 3, 5, maybe 7 pounds of fuel. We're compared to what we're doing in fuel injection, which we're going hundreds. Now we're going to thousands of PSI with our direct injection systems. But the idea was if the float, so this is a float that kind of floated on top of the fuel. It was made of a material, or it was actually hollow, so it would float on top of the fuel to close that seat when we that needle and seat when we got to the point where the fuel was at ample enough. Now, this is one of the critical adjustments you did when you did a overhaul on a carburetor. So as the float would drop, we'd allow more fuel to come in, and as the fuel was high enough, the float would cause it to shut, or almost shut, the actual supply of fuel coming in. And then we had what we called our idle circuit. Now, as the throttle completely closed, well, it didn't 100% close, but it closed quite a bit, and we would have stalling. So we would actually not have enough fuel to support the cylinders on the engine. So we had a idle circuit. So in other words, coming out of the float wall, there was another little jet down here, and that jet allowed a certain amount of fuel to be pulled in through a Venturi type of effect. So we would, from the intake manifold, which would be down here, we would actually allow fuel to be adjusted. So this was that mixture screw that we had on our carburetors. And then we had off idle circuits where the throttle plate would open up a little bit, and it would allow a little bit more fuel to come through. And then if we go far enough off, depending on what kind of carburetor we had, it would actually have more sources of fuel to get things started. This was not it was just off the idle circuit. So it was not the full way the carburetor pulled fuel in. Then after that, I kind of want to show you what it looks like on the carburetor from the bottom view of it. So if you look at the bottom of the carburetor here, you would see these for the off idle ports. So we would have the adjustment screw. You could see that. And then if you opened up the throttle plate a little more, you might see some more holes that would actually allow more fuel to come through. So after we went off the idle circuit, then we went into a acceleration system. This would actually squirt one. We'd have an accelerator pump. It was a mechanical type device. These cup assemblies would actually allow fuel to be pumped up through a check ball. So in other words, we didn't pull fuel back, and we had a check ball here too. This will allow fuel to be sprayed out and to assist in accelerating. And the mechanical part of it, depending on your carburetor, would have some linkage and some rods that allow it to actually mechanically push. Because remember, we didn't have the electronic throttle controls. It was all mechanical. So that push on the throttle from the accelerator pedal would actually transmit either through a cable or a rod going in to connected to that carburetor to make the mechanical effect happen. And our accelerator diaphragms, like here, we had an adjustment on this particular one. Some of them didn't even have adjustment. You just had to do the best you could to make sure the rods were connected, and some would have stepped linkage. So like this one has a hole here and a hole here, so we can actually adjust it that way. But on this particular one, we actually had a screw that, a nut, I should say, that allow it to adjust across to give to adjust that to the precise amount of fuel to be down there without making it so it stall if we had too much or too little. And there are different types of accelerator pumps. It wasn't just the cup type shape. We actually had diaphragm type shapes on a lot of the Holleys and some of the motorcrafts and stuff like that. Primarily Holley, that would actually pump the extra fuel that it needed. And then when we went into the high speed, we used that Venturi pull. And remember, I told you to remember what we did. Well, if you look at the way air flows. And if we put it across a Venturi, it's going to allow it to pull fuel across. And this is a Venturi action. There we have a main jet right here coming across and allowing the fuel to come down and start atomizing. The goal was to get the fuel to atomize correctly, which was the big challenge, especially with carburation. And then we had the full throttle. So we had the throttle plate all the way open. And then we had on a lot of carburetors, almost all of them, we had a booster Venturi that will allow it to pull even more fuel through. And then we would have a metering jet on some of the carburetors to allow it to actually open up a little bit farther to allow more fuel to come across. And again, it was all cable driven, or linkage driven, I should say. And our metering rod action would actually, metering rod would open and then close to allow more or less. So we'd have a richer mixture or a leaner mixture, depending on what the needs were. And then some of the carburetors also had what they called a power valve. And it was a vacuum driven or vacuum controlled valve that would actually allow, instead of that rod going up and down, we actually had a power valve that would pull open a little more fuel going through the different through the Venturi action right here. So as the power, if we have low power, you kind of high vacuum in the intake manifold, that diaphragm stayed at a certain point. And then when we went to high power, low vacuum, that would actually move up. You see this right here, and allow fuel to kind of cross across, a little bit more fuel coming across. All right, so then there was the choke circuit. There again, we had another circuit that you don't see in carburation. In fuel injection, I'm sorry. But with the carburation part, we had another, and sometimes they called it the butterfly, but we had another plate up on top that was mechanically controlled again. And this would be connected to a actual thermostatic spring, and this would heat up and change and kind of uncoil itself to allow it to actually have a little more opening or close it. So when it was cold, the spring would be all kind of sprung, kind of really sprung out. And when it heated up, it kind of moved its coil into a smaller ball, and that allowed the plate to open and close. We also had we could have it electrically controlled, or we could have it just heat control. And some of the exhaust manifolds and some of the intake manifolds, we had a heat source, so we would kind of guide that heat source going on through to actually heat up that coil to allow the plate to open up. To assist with that too, for first thing in the morning when it's cold, we would have the throttle plate completely shut. And this was part of the adjustments you would have to do in your overhauls too. So it would be completely shut. And as the car started started cranking over, we'd have a little bit of a vacuum source down here. And there was different types of choke pulls, not just one style, but this is a vacuum controlled one from the inside the carburetor itself through a channel. But we would actually have out sourced ones too, would pull vacuum when the car started cranking too. So a different style altogether. And then as it heated up, the coil would kind of tighten up, and then it would actually allow the throttle plate to open up. And like I said before, we had a different type. We had this one actually with an electric one. We also had a deceleration circuit. On this particular one, we had a deceleration pod. So one of the downsides of carburation too is with the flat or bottom type intakes is we had a pulling effect. In other words, not all fuel would be atomized as it goes across, especially when the carburetor, the engine was cold. And when they do a pulling effect on the bottom of the intake manifold. And then when you accelerate and decelerate fast, a big rich mixture would be pulled into the cylinders, and this is what we didn't want. Plus, sometimes you get the banging effect going on too. So this was when you accelerate real hard, and it didn't slow it down really fast, but it slowed it down just enough that it wouldn't allow that extra boost of fuel to be pulled into the different cylinders. And I kind of talked a little bit about this, but that unloader part of it, when it had that little bit of vacuum pull, and then we actually had another, part of it too on some of the carburetors where we had stepped, which all of them did. When it was cold, we inject and we can bring up the idle speed a little bit more. And then on some cars, they had what they called a choke unloader. So that unloader, when you accelerated hard, would allow it the cam to a little bit of weight on the cam would allow it to step down a little bit. And as the choke started opening up a little bit more, that would go down to the regular idle speed. And this is, what I was talking about a minute ago, the fast cams. We brought it up when the choke was cold, and then we let it come down to idle speed a little bit later on. And depending on the carburetor you had, to adjust for the idle speed, and also for maybe you had a car with air conditioning, the air conditioning puts more of a load on the engine. So we adjusted through a solenoid to step that up a little bit with the air conditioning on. So this was one of the things we had too. And I did talk about the deceleration dash pod just a minute ago. Now, some of the ports that we had on carburation, the ports we had was, of course, we had different positions of the throttle plate. So we had different ports in it. So we had an intake port, so it'd be manifold vacuum coming across here. And then we had a no vacuum on idle, but as it accelerated, we would actually pull an off idle port or a ported source. And then if you went up farther, which this diagram doesn't show, we had an actual Venturi effect, right? We'd have a port going right across the Venturi. Some manufacturers use this for some signaling processes. And then there was different barrel assemblies. We had a single barrel, so that means the opening on the carburetor at the bottom would be single barrel. And then we had two barrel, so you would have two barrels down here. And this has helped with the different vehicles for bringing the fuel to where it needs to be a little bit more, not precisely, but a little bit better. And then, of course, you had the 4-barrel carburetors. So some, racers would have a tri-pack, would be like three 2 barrels. If you're really a heavy-duty racer, which would probably put it overfueled and would not allow the car to run correctly. Please understand that the bigger sizes of carburetor doesn't necessarily mean it's going to run better. I've cured a lot of drivability problems just by putting the right carburetor on it. I had a friend of mine that he decided that more carburation was better, and he really complained about, after he put the 650 on his car, the car stopped running as good as it did with the old carburetor. And what had happened, it was overfueling. So anytime he really accelerated really hard, it just put black smoke out of the tailpipe. And that was because the size of the carburetor, the amount of fuel it could pump out. You need to know how much flow rate is going through your engine to really precisely put the correct carburetor on it. So Holley's did their like 650s, in different sizes. I'm not going to go through all of them, but I just brought up the 650 a minute ago. So anyways, this is kind of what I wanted to start off with, but we'll be getting deeper into carburation as we go along. And then I'll be putting another video together really quickly on fuel injection. I might even put some more stuff together on carburation too as we go along. But yeah, I hope this is beneficial. If it was, please, of course, like and subscribe. If there's any suggestions you want to bring into it, please write them down in the comment part. I read every one of the comments, and I appreciate the comments, and I appreciate all the subscribers. And you that would like to subscribe, please do hit the like button and all that good stuff. All right, I'll talk to you all soon, and we'll have some more fun. Talk to you soon. Bye for now.